Workers are pouring 16 tons of molten steel soup into two huge casting ladles. This is the manufacturing factory of the German super diesel engine MTU 8000. It is the most powerful and fastest diesel engine in the world. For MTU 8000, super engines are installed on this most advanced Mediterranean conjoined ferry. They enable this 1,500-ton conjoined ferry to accelerate to a maximum speed of 42 knots, which is equivalent to 75 kilometers per hour. This engine is a 20-cylinder common rail diesel engine. It is 7 meters long, 2 meters wide, and 3.5 meters high. The entire engine unit is almost the same size as a steam locomotive, weighing 48 tons, with 20 cylinders. It has a displacement of 350 liters, delivers 13,600 horsepower, and can consume 2,000 liters of fuel per hour. The largest and most crucial component among them is the huge crankcase. Let's take a look today at how it's manufactured. The manufacturing of the entire engine comes from this German foundry. As early as the 15th century, this place was just a small blacksmith shop. They have a tradition of forging and casting iron into shape that spans more than 600 years. Now, the 3 blast furnaces in the foundry are running at a high speed. What the workers are manufacturing is the crankcase of the MTU 8000 super engine. These are the raw materials used to cast the super engine, mainly including scrap steel, pig iron, artificial graphite, silicon carbide, and so on. Casting such a crankcase requires consuming 16 tons of raw materials. Workers need to constantly pay attention to the temperature of the furnace. The molten steel can only be transported to the mold for casting when the furnace reaches a temperature of 1500 degrees. During this process, the workers need to continuously insert the measuring tube with a temperature sensor head into the furnace to take measurements. Whenever a different temperature is reached, the workers will correspondingly add raw materials to the furnace. This is the only way to ensure the hardness and toughness of the crankcase. From time to time, they also scoop out a spoonful to taste it. They pour the molten steel soup into a sample crucible. Inside the crucible, there is a small measuring tube, which is used to measure the process of temperature change and transmit the results to the computer, the adjacent office. If the molten steel soup cools according to the predetermined process, it proves that the proportion of raw materials is correct. The huge amount of heat energy is generated by electricity, which has the same principle as the household induction cooker. The difference is that 3 power frequency induction melting furnaces are used here. They have the energy equivalent to 5,000 microwave ovens and a power output of up to 4 megawatts. When the temperature finally reaches 1500 degrees, the workers need to pour out this molten steel soup. At this time, the workers need to use a chute to add one more ingredient, that is, magnesium. When magnesium is at this temperature, it will instantly turn into a vapor state. It will pass through the red-hot metal just like the carbon dioxide in a cola. Its function is to change the network structure of iron molecules, making the crankcase more ductile. After everything is ready, the 16-ton molten steel soup will be poured into 2 huge casting ladles. Since the casting mold for the crankcase has only 2 pouring inlets, this is the casting mold for a single part. It is composed of resin quartz sand that has been soaked. After it hardens, it becomes as hard as stone. 10 of these single-piece cores make up the entire casting mold for the super engine's crankcase. Before casting, a coating will be applied to each mold. This intermediate layer has a strong odor, and its function is to prevent the sand from sticking to the steel during the casting process. When the molten steel soup flows into the mold through this pipeline, there is a ceramic filter inside, and then it flows into the mold through these slots. These 10 single-piece molds are first placed into a casting frame. This is the casting frame for casting the MTU 8000 super engine. At this time, the workers need to fill it with sand. Without this sand, the components of the mold may be blown away during the casting process. The entire process of filling the sand requires the workers to have great experience. because any mistake in filling the sand may lead to the scrapping of the mold. Then comes the pouring of the molten steel soup. During this process, the workers need to keep measuring the temperature of the molten steel, and the temperature must never drop below 1400 degrees. The huge overhead traveling crane transports the ladle to the mold, and this process requires great care. The molten steel is slowly poured into the casting hopper. When the worker pulls the operating lever of the valve, the 16 tons of liquid molten steel can flow into the entire mold and fill every cavity in the mold in just 70 seconds. The casting is completed after 1 minute. This molten steel soup needs to cool inside the mold for 2 weeks. After 2 weeks, the workers will remove the crankshaft from the mold. They use a crane to lift it up, and at this time, the quartz sand shell starts to separate. What is presented in front of them is the brand new crankcase of the MTU 8000 super engine. Then, the welders will cut off the 2 iron columns formed by the injection. There are still many redundant parts on the 7-meter long casting, and the workers need to cut them off one by one. The cut-off materials can be recycled and reused for the next casting. Subsequently, the crankcase is lifted by a crane onto a huge vibrating plate. As the vibration intensifies, the quartz sand adhering to the casting keeps falling off. These quartz sands will also be recycled and reused. 3 minutes later, this super crankcase is transported to the shop blasting room. In the shop blasting room, it will be subjected to the impact of tens of thousands of steel balls. These steel balls, traveling at a speed of 200 kilometers per hour, will clean the surface of the casting thoroughly. After the whole process lasts for an hour, what emerges is an astonishing engineering marvel. Next, it's time to install this super engine. This factory produces 25 super engines every year. First, the casting needs to be sent to the milling workshop. Here, there will be a day for the lathe to polish this crankcase. The precision of the polishing machine needs to be accurate to 1/400th of a millimeter, which means that for a machine as large as a bus, the error should not exceed 1% of the thickness of a human hair. After that, it will be sent to the measuring room for measurement. The technicians need to measure each opening. Only when everything is okay will the final assembly process begin. 35 assembly technicians will spend 5 weeks on the final installation. First, it is lifted onto the rotating platform. At this time, the crankcase will be assigned a serial number, which the worker will engrave on it using a machine. The worker needs to check again whether there are any remaining impurities. Even tiny pollutants like dust or iron filings may lead to catastrophic consequences. Next are these camshaft components. After being assembled together, they are 6 meters long and weigh 400 kilograms. The worker first immerses the component pins in liquid nitrogen at -198 degrees Celsius for cooling. The pins, which decrease in volume due to the low temperature, can just fit into the flanges of the camshaft. When they are reheated, they will expand and then become firmly fixed. Then, lubricating oil is applied. After that, the 6-meter-long camshaft is stuffed into the installation channel. At this time, it needs to be installed section by section, and any misalignment is not allowed. Otherwise, the motor will be jammed. After the 3 sections of the shaft are fixed with screws, it is carefully pushed into the engine. The camshaft is made of strengthened steel, so it doesn't need to be replaced throughout its lifetime. Up to this point, the work of the first installation station is completed, and this super engine will move on to the next station for further installation. The German MTU 8000 super engine is placed on another rotating platform. The crankcase is the largest part of the super engine, and now the second largest part being lifted is the crankshaft, which is the center of rotation and pivot of the engine. The crankshaft is 6 meters long and weighs 6,000 kilograms. When operating at full speed, it can rotate 20 times per second. To install it, the engine must be turned upside down. The crane lifts the crankshaft towards the engine block, and after 20 minutes, the crankshaft is installed. The worker needs to rotate the huge base a few degrees more before assembling the piston. The connecting rod needs to be measured and recorded. First, prepare the piston, which has a diameter of 720 centimeters. Then, lift the 100-kilogram connecting rod and slowly place it into the piston, and then insert bolts to fix it. It takes 15 minutes to install one piston, and a total of 20 pistons need to be installed. What's even more complicated is the piston head. First, 4 bolts need to be installed. Then, the so-called cylinder liner needs to be placed on it, and it is fixed with 24 bolts. This is a fully automatic device that monitors the whole process to prevent workers from forgetting to tighten the bolts. Next, the piston connecting rod is installed into the cylinder liner. Finally, a part of the exhaust pipe is installed. The single cylinder is slowly lowered into the super engine by the crane. Inside, the connecting rod fits the crankshaft precisely. Then, the connecting rod is temporarily fixed with white plastic parts. The engine is rotated again to install 20 sets of bottom connecting rod covers, each weighing 25 kilograms. The up and down movement of the piston makes the crankshaft rotate 20 times per second, which requires withstanding extremely high forces continuously for decades. The connecting rod is strengthened through a special process. At this time, the worker connects the hydraulic awl pipe. The hydraulic cylinder uses a pressure of 1600 pascals to stretch the bolts, and then the installation is completed. Next comes the installation of the fuel pipeline, exhaust pipeline, and cooling system. At the third station, the gear transmission box needs to be installed. First, a special sealant is applied, and then the cover weighing 200 kilograms is installed. This super engine can operate for more than 35 years without the need for maintenance. Next, the turbocharging module is installed. It is composed of thousands of components and can greatly enhance the performance of the diesel engine. The factory needs a week to install this 2-ton turbocharging module. After the installation is completed, it is fixed onto the super engine and to workers connected to the exhaust gas recirculation system. At this point, the weight of this engine has reached 40 tons. Then, a hydraulic device is used to gradually press the clutch onto the crankshaft. The second part of the clutch can be fixed simply with bolts. After that, this 40-ton machine is lifted above the awl pan, which is placed on 6 pillars. The awl pan has a capacity of 1,600 liters. After the installation is completed, it enters the final station for installing the electronic components. Hundreds of meters of copper pipes, cables, and hoses are installed both inside and outside the engine. Each pipeline is produced by the factory itself and then connected. These pipeline parts are almost all made of alloys of copper, nickel, and iron, ensuring that they will not be corroded even when submerged in seawater. In the past 5 weeks, nearly 20,000 parts have been installed on this engine. Up to this point, the engine has been manufactured. Finally, after going through 46 testing procedures and 5 hours of cleaning work, the workers wrap the key pipelines and spray paint on it before it can be officially delivered for use.